So we're going to look at a particle. And the particle is going to have a mass of m. It's going to be projected vertically up. And it's going to experience a resisted force. So it's going to experience a resisted force of mkV. Okay, so what we want to do is we want to be able to get T in terms of V, and then V in terms of T, and then X in terms of V, and then V in terms of X. So we're going to derive all of these equations. So the thing is going up, so that means plus is up, minus is down the bottom. The force mg would be negative, and there is a resistant force of minus kV. Okay, so looking at this now, that means the sum of the forces would be minus mkV minus mg. So mass times acceleration is minus kV minus mg. The m's cancel, so you get minus kV plus g. So now deriving the equation of motion, if I want to get time, I need dv on dt equals minus kV plus g. So that means 1 on kV plus g dv equals minus 1 dt. Integrate. Now we could do it because we're going up, so that's going to be x is 0, time is 0, and v will be mu. I should have said that the initial velocity will equal mu. So if you integrate within the boundaries, I'll do it for this one, and then the next one I won't. So this is time. So time is 0. So time is 0, and that will go up to t. This one here, we're going to start at mu, and we're going to go up to v. Now, how do you integrate this left-hand side? It's a log, because you can create the derivative, which is k. So it'll be 1 on k, ln kv plus g, and we're going from u up to v, and this is minus t from 0 up to t. So that's minus t minus 0, which is minus t, and this is 1 on k ln kv plus g minus 1 on k ln k mu plus g. So it's 1 on k ln kv plus g on ku plus g equals minus t. T equals minus 1 on k ln ku plus g kv plus g, sorry, on k mu plus g. Now that negative there, if you bring it up and you make it an indice, kv plus g on k mu plus g, you make it minus 1, because you can bring that things up there, but it becomes an indice, then that just flips it. So it's ku plus g on kv plus g equals t. So that's okay. Now what I have here is that I have the time in terms of v. So the question is now, can I take the time that is in terms of v, and can I make v in terms of the time? So let's have a look at this. So I've got t is 1 on k ln ku or mu plus g over kv plus g. So bring the k over, and you get kt equals ln ku plus g over kv plus g. So that's a log base e. So you go e to the kt equals ku plus g on kv plus g. Now we're going to get v by itself, because it's kv plus g e to the kt equals ku plus g. kv e to the kt plus g e to the kt equals ku plus g. And what I'm trying to do here is just get v by itself. So get rid of, what I'm going to do actually, I'll take the KT out, e to the KT out. So you can see that's KV there. KV plus G equals KU plus G. And then I'm going to bring that to the other side and I'm going to divide it. So it's KU plus G over e to the KT. And when I bring that up, it'll give me a negative. So KV plus G equals KU plus G times e to the minus KT. So KV equals KU plus G e to the minus KT minus G. And then V equals KU plus G e to the minus KT minus G. That will be over K. And this one here will also be over K. So V equals, that'll be mu plus G on K e to the minus KT minus G on K. Okay, so far I have got T in terms of V, V in terms of T. Now, can we now do X in terms of V? So we've got the acceleration. Let's go back to the base one. So that's minus, so it's going to be G minus KV. Okay, so plus